Hi, in this video we will learn how one can relate system of linear equations. The part that we covered in chapter 2 are related to matrices, what are we covering in chapter 3. So this is something that we write it as matrix form of a system, and we will see how this will be useful later. Okay, so let us start with an example. I have a system of linear equations, 2x plus y equals to 1 and minus x plus 2y is equals to 0. I look at these equations one by one and I notice that, well, you see here I have 2, 1. If I form this matrix which has 1 rows and 2 columns, and then if I multiply this matrix by a matrix which has the variables in it, x and y. Since this matrix is 2 by 1, the product, the multiplication, matrix multiplication is defined, and the result is going to be a 1 by 1 matrix. Well, 1 by 1 matrix is number. We don't put bracket for that. And in this case, it will give us equal to 1. Well, we can do the same thing for the second equation. xy, and then this is going to be equal to 0. Well, now for each equation, you do this thing, and you see this part is the same. I have different rows. Now put all those rows in a matrix. So this will be 2, 1, and negative 1, 2. Then when you multiply it to xy, you will get 1, 0. Well, you have to check this at this stage that this matrix multiplication or matrix equation is well defined. Why? Because this is 2 by 2, this is 2 by 1. Then the result is 2 by 1 matrix. This is what is called matrix form. Okay, so in general, matrix form of an SLE. So in general, if you have a system of linear equations, something like this, we can write a given system of linear equations like this in its matrix form. What is its matrix form? Well, it will have 2 parts on the left and 1 part on the right. What is on the left side? The left side has 2 pieces. One is the coefficients of the variables. And this goes up to AM1, AM2 goes up to AMN. And then the second part of the left-hand side is the variable side. So we have x1 up to xn. How about the right-hand side? Each equation gives us one constant term. So we have b1, b2. This goes up to bm. Well, this matrix is called the coefficient matrix. XYZ is the variable matrix, so I don't write in. The other one, the right hand side, is called the constant term. Basically what we write here is that this is A, well, this is coefficient matrix. times x equals to b. So this form is called matrix form. Okay, so let's just do some examples. Here I have some of these ones. Well, this one, for example, the matrix form will be 2, -1, -1 times x, y, z. Put all the coefficients as this matrix. And that's the right answer. How about this one? Well, this will have 1, 2, -3, 0, 0, 1, 1, and -1 times x1, x2, x3, and x4. How about the right hand side, the constant terms? This is -1 and 2. What about this one? Well, this is 2, 3, 1, 2, x, y, and this is a 3, 1. Well, you say, okay, what does this mean? Why this is an important thing, or why it is useful, this form, matrix form? Why matrix form? Well, something that you can see in the matrix form, when you write it, it's ax equals to b. This should, well, sometimes these are vectors, well, in a little bit different form, but those are matrices, yes. Sometimes this resembles equations like this: 2x equals to 1. Yes, the A is, instead of a matrix, here is a number. Yeah, and then we have x, the variable here, x, the variable. The right hand side, B, here is one number. Remember, how did we solve these equations? So 2x plus 1, you would usually say, well, divide 2 to the right hand side. But in practice, what we do for solving these systems is that we multiply both sides by the inverse of the coefficient, here just 2. And then what happens is that coefficient times its inverse, it gives us 1. So 1 times x is 1/2 times 1. And then x is equal to half. Basically, by multiplying both sides by the coefficient of inverse of the coefficient of x, we were able to solve this. Now, if your matrix has inverse, so if A is invertible, we can kind of do the steps that we had for the numbers. But we can do A inverse times the whole ax is going to be equal to A inverse b. And this is A inverse A times x, A inverse b. A inverse times x is identity times x equals to A inverse b. Well, identity times any matrix is that matrix. So that is what we have. We can solve the equation, the system of linear equation, if we know what is A inverse, as we did for the numerical equations. Okay, so this is what is called the inverse matrix method, and we will cover it in another video.